Stop looking at the screen. Look at the room around you, the walls, the air, the space between your eyes in this video. You think it's empty space, right? You think you're sitting on a rock, floating in a calm, infinite void. Wrong. You are inside a monster. For 100 years, we've been terrified of black holes. We treat them like cosmic vacuum cleaners that destroy everything they touch. But there is a mathematical coincidence that keeps physicists awake at night, a number that shouldn't match, but it does. Perfectly. Here is the fact that's going to break your brain. If you take all the mass in our observable universe, every star, every galaxy, every cloud of gas, and you crunch the numbers to see how big a black hole that much mass would create, you get a size that is exactly the size of our universe. Do you understand what that implies? It implies that the Big Bang wasn't an explosion. It was a collapse. It implies that the event horizon isn't out there, billions of light years away, waiting to eat us. It's behind you. It's around you. You are already living inside the event horizon, and I can prove it to you. Let me show you. Most people think a black hole is a cosmic vacuum cleaner, like a drain in a bathtub. You get close, you get sucked in, crushed, dead. That's a cartoon. That's not physics. Here's the trap everyone falls into. You think of a black hole as an object sitting in space like a dark star, but a black hole isn't an object. It's a place where the rules of the game change so violently that space itself stops existing. Do this right now. Close your eyes. Imagine a river, a wide, smooth river flowing towards a waterfall. If you are a fish swimming upstream away from the edge, you're fine. The water is slow. But as you get closer to the drop, the water speeds up. Eventually, there is a point, an invisible line, where the water flows faster than you can swim. Even if you swim at the speed of light, the water is dragging you backward faster than light. That line, that is the event horizon. A black hole isn't sucking you in. It's space itself falling like a waterfall. Space is cascading down into a bottomless pit, dragging you with it. But here is where your intuition fails. Once you cross that line, the event horizon, something impossible happens to the geometry of reality. Space and time swap jobs. I'm serious. Look at the equations. In general relativity, the mathematical sign for distance and time literally flips. Outside the black hole, you can move left, right, up, down. You have freedom in space, but you are a prisoner of time. You are forced to move forward towards tomorrow. You can't stop time. Inside the black hole, it flips. Inside, space becomes like time. It flows in one direction only, inward. You can't turn around and go back to the event horizon any more than you can turn around and go back to last Tuesday. And the center, the singularity, it's not a place in the middle. Because space is now time, the singularity becomes a time. It becomes the future, no matter where you turn. No matter how hard you fire your rockets, you will hit the singularity just like you will hit next Friday. It is an inevitable moment in your future. Now pause. Look at our universe. We can move anywhere we want in space, but we are dragged relentlessly forward in time. We are expanding towards a mysterious future we cannot avoid. Does that sound familiar? It should, because the math of a universe expanding and the math of a black hole collapsing are suspiciously identical. So if we are inside, where did we come from? We are told a story in school. In the beginning, there was nothing. Then, boom, everything. The Big Bang, we treat it like a grenade going off in an empty room. Shrapnel flying everywhere, but that's lazy thinking. That's a convenient lie. If the Big Bang was an explosion, where is the center? If a grenade goes off, you can point to the crater. You can say, it started there. But look at the universe. Point your telescope left. Galaxies moving away. Point it right. Galaxies moving away. Up, down. Every single point in the universe looks like the center. That sounds impossible until you see the trick. The Big Bang wasn't an explosion in space. It was an explosion of space. But let's get darker. What if the Big Bang wasn't the beginning? What if it was the end? Think about a star in a parent universe, a massive dying giant. It runs out of fuel. Gravity wins. It collapses inward. It shrinks, smaller, denser, hotter. To an observer in that parent universe, that star just vanished. It blinked out of existence and became a black hole, a dead end. But wait, what does it look like from the inside? From the perspective of the material falling in, it's not vanishing. It's getting crushed into a single point of infinite density. But remember chapter 1, space and time flip. The collapse on the outside looks like an expansion on the inside. As the star collapses, it creates a new region of space-time that is cut off from the parent universe. To the matter inside, it feels like space is suddenly stretching out in all directions. It feels hot, it feels dense, it feels like a big bang. This is the white hole theory. What looks like a black hole eating matter in one universe looks like a white hole spitting out a big bang in a new universe. They are two sides of the same coin. Now watch what this implies. It means our beginning 13.8 billion years ago wasn't a random accident. It was the death of a star in a higher dimension. We are the debris. We are the leftovers of a cosmic collapse. You might say, but wait, if we are inside a black hole, why don't we see the walls? Why can't I see the edge? Because you're looking at it wrong. The walls aren't where you think they are. They're hiding in plain sight. Look out the window. Go ahead. Does the world look like it has a wall? No. It looks infinite. You see trees, buildings, sky. You see stars billions of light years away. So if we are inside a black hole, where is the event horizon? Where is the edge that keeps us trapped? This is where your intuition fails. You are imagining a black hole like a prison cell. 4 walls, a ceiling, a floor. You think if you fly far enough, you'll smack into a cosmic wall and bounce off. Wrong. The event horizon isn't a wall in space. It's a horizon in time. Think about the horizon on Earth. You stand on the beach, you look at the ocean, you see a line where the water meets the sky. Can you sail to that line? Can you touch it? No. As you sail towards it, the horizon moves away. It always stays exactly the same distance from you. You can sail forever and never reach the edge. The Earth is finite, but your journey feels infinite. Hold on, don't scroll. This is where Einstein got scared. A black hole does the same trick with light. Inside the event horizon, space is curved so violently that light travels in closed loops or spirals. If you shine a flashlight forward, the light beams don't go out into the void. They curve around the curvature of the universe and theoretically could hit you in the back of the head. But because space is expanding so fast, remember the waterfall? The light can never quite make the full loop. It just keeps traveling forever. To you inside the ship, it looks like the light is going in a straight line through infinite space. You see galaxies ahead of you. You see galaxies behind you. It looks flat. It looks endless. But here's the part that makes zero sense until you look at the math. The edge is there. It's the cosmic microwave background radiation, that wall of fire at the edge of the observable universe, the afterglow of the Big Bang, that might literally be the inside surface of the event horizon, the boundary we can never cross, the point where the waterfall of space is falling faster than light, so we can never see what's beyond it. We are trapped in a bubble of light, convinced it's an infinite ocean. And the reason we can't escape isn't because there's a wall. It's because space itself is betraying us. It's stretching. Let's talk about the biggest mystery in modern physics, the one that keeps astronomers awake. The universe is expanding. We all know this. Hubble found it. The space between galaxies is getting bigger every second. But here's the weird part. It's accelerating. Imagine you throw a ball in the air. Gravity pulls it down. It slows down, right? Wrong. In our universe, you throw the ball up and it rockets away faster and faster, like something is pushing it, like gravity is broken. Scientists call this dark energy. It's a placeholder. Name for we have no idea what is happening. It sounds like magic. But wait, what if it's not magic? What if it's just perspective? Imagine you are falling into a black hole again. Remember the waterfall. As you fall, the gravity gets stronger. The space stretches. If you are falling feet first, your feet are closer to the singularity than your head. The gravity on your feet is stronger. It pulls them harder. Your body stretches. This is called spaghettification. Now imagine the universe is falling into a higher dimensional black hole. The space itself is being pulled towards a singularity in the future. The galaxies aren't flying apart because of some mysterious dark energy. They are falling apart. They are being spaghettified. The space between them is stretching because they are in free fall towards a singularity we can't see. This is the secret that Stephen Hawking took to his grave. To an observer inside the black hole, that's us. It looks like the universe is expanding. It looks like a repulsive force pushing galaxies away. But to an observer outside, it looks like the entire universe is collapsing. It's the same event, two different perspectives. Inside expansion, dark energy, outside collapse, black hole. The math of an expanding universe, Friedmann equations, is eerily similar to the math of a collapsing star. Oppenheimer-Snyder collapse, they are mirror images. Nobody talks about this part of the equation because it implies something terrifying. It implies that dark energy isn't a force. It's an illusion. It's the sensation of falling. We aren't expanding into an infinite void. We are falling into a singular point in time. And this leads us to the craziest idea of all. If we are falling, where is all the information going? Information, not books, not the internet, not your thoughts. I mean quantum information, the raw data that describes every particle in the universe, mass, spin, charge, position, momentum. Physics says this data cannot be destroyed. If you throw a book into a black hole, does the information vanish? This is where Einstein got scared. For decades, we thought black holes erased information. Hawking said yes, then he said no. He changed his mind. Why? Because of something called the holographic principle. Imagine a soda can. It has a label on the outside. The label tells you exactly what's inside. The ingredients, the volume, the flavor, all the information about the inside is written on the outside. Now imagine the universe is a soda can. The label is the event horizon. It is a 2D surface at the back edge of the universe. All the information about everything inside, every star, every planet, every atom in your body is actually encoded on that surface. Wait, let that sink in for a second. This sounds like science fiction, but the math works perfectly. String theory suggests our entire 3D reality is just a projection, a hologram, like a movie on a screen. The film is 2D, but when you project it, it looks 3D. It has depth. You can walk around in it. But if you look closely enough, it's flat. And this is where the picture gets terrifying. If the universe is a hologram, then the real information is on the boundary, on the surface of the black hole. We are inside. We are the projection. We are the shadows on the wall of the cave. The reason gravity is so weak compared to the other forces, you can pick up a paperclip with a tiny magnet against the entire gravity of Earth, might be because gravity isn't even a real force in 3D space. It's a side effect. It's the curvature of the projection. It leaks into our dimension from the surface. This theory solves the biggest headache in physics, why quantum mechanics, small stuff, and gravity, big stuff, hate each other. If the universe is a hologram inside a black hole, gravity makes sense. It's an emergent property. It's not fundamental. We are living inside a giant quantum computer, and the hard drive is the surface of the black hole. But who built the computer? Or better yet, why is it so perfect for life? Let me ask you something weird. Why is the universe perfect for us? The sun is the right, is the distance. Water freezes and boils at the right temperatures. Gravity is just strong enough to hold us down but not crush us. If you change gravity by 1%, stars wouldn't burn, atoms wouldn't bond, we wouldn't exist. This is the fine-tuning problem. Scientists hate it. It sounds like God. It sounds like intelligent design. But there is a darker answer. You think that's a coincidence? Nature doesn't do coincidences. What if universes evolve like animals, like bacteria, like us? Think about Darwin, survival of the fittest. The creatures that are best at reproducing make more babies. Now apply that to universes. What if the babies of a universe are black holes? A black hole is born when a massive star collapses. It creates a new baby universe inside. Remember chapter 2? Now imagine this. Universes that are good at making black holes create more baby universes. Universes that are bad at making black holes die out without offspring. So over billions of generations, the multiverse fills up with universes that are experts at making stars and black holes. And here is the kicker. The exact same laws of physics required to make black holes are the exact same laws required to make life. To make a black hole, you need stars. To make stars, you need gravity, carbon, nuclear fusion. To make life, you need stars, gravity, carbon. We are not special. We are a side effect. We are just mold growing on the reproductive organs of a universe designed to make black holes. This is Lee Smolin's theory of cosmological natural selection. It explains why the constants of nature are so perfect. Because if they weren't, this universe wouldn't have been born. It inherited its DNA from its parent universe. A universe with slightly different laws wouldn't have stars. It wouldn't have black holes. It would be sterile, a dead end. But our universe, it's fertile. It's teeming with black holes. It's making trillions of babies. This is going to sound crazy, but the math demands it. If this is true, then every black hole in our sky is a gateway to another reality, another universe with its own stars, its own planets, maybe even its own life. And we are living inside one of them. We are the children of a dead star in a higher dimension. But can we prove it? Is there a way to verify this insane idea? Yes. We just need to weigh the universe. Let's stop being philosophers. Let's do the math. Physics isn't about feelings. It's about numbers. If I'm wrong, the numbers should fail. So let's weigh the universe. We need two numbers. Mass. How much stuff is in the observable universe? Stars, galaxies, dark matter, everything. Scientists have estimated this. It's huge. About 1053 kilodalton. That's a 1 with 53 zeros. Radius. How big is the observable universe? About 46 billion light years, or 4.41026 m. Now let's use a formula from 1916. Karl Schwarzschild. He was the first guy to solve Einstein's equations for a black hole. He found the Schwarz radius. It's simple. R s fastas c2 gm. G is gravity. M is mass. C is the speed of light. This formula tells you if you have this much mass, how small do you have to squeeze it to make a black hole? Or flip it around. If you have this much mass, how big would the black hole be? Now watch what this implies. Let's plug in the mass of our universe into Schwarzschild's equation. Do the math. Calculate RS. The answer comes out to 4.41026 m. Wait, stop. Look at that number again. The radius of a black hole with the mass of our universe is the exact radius of our universe. It matches perfectly. This isn't a rounding error. This isn't close enough. This is a bullseye. If the universe wasn't a black hole, this number should be wildly different. It should be way smaller or way bigger, but it's identical. That's not science fiction. That's just geometry. This is the smoking gun, the mathematical proof that we satisfy the condition for being inside a black hole. Our density is exactly the density required to be a black hole. You might say, but wait, black holes are supposed to be super dense, crushed matter. I'm not crushed. Wrong. The bigger a black hole gets, the less dense it needs to be. A black hole the size of Earth, super dense. A teaspoon weighs 1 billion tons. A black hole the size of the solar system, less dense, like water. A black hole the size of the universe, it has the density of empty space. With a few atoms here and there like us, we are living in a low-density black hole. We are floating inside the event horizon of a monstrously large object. And if that's true, what is inside the black holes in our universe? Are there universes inside them? And are there universes inside those? You know those Russian dolls, the wooden ones? You open one, there's a smaller one inside. You open that one, there's another. It goes on and on. What if the universe is a Russian doll? We are inside a black hole. Let's call it Universe A. Inside Universe A, our universe, we have stars. Some of those stars collapse and form black holes. Let's call those Universe B. Inside Universe B, maybe there are stars too. Maybe they collapse and form Universe C. And inside Universe C, wait, let that sink in for a second. It's infinite down and up. We might be inside Universe A, which is inside a super black hole in Universe 0, which is inside a hyper black hole in Universe -1. This is the nested universe theory, or the cosmological natural selection on steroids. Each layer is a universe. Each black hole is a womb. But here is the scary part. If every black hole contains a universe, and every universe contains black holes, then there are trillions of universes inside our own right now. Every time a star dies in our sky, a big bang happens somewhere else. A new reality is born. We are walking around with entire cosmoses in our pockets, and we are just one tiny bubble in an infinite foam of bubbles. This is where the picture gets terrifying, because if this is true, it changes everything we know about time. Time in our universe started 13.8 billion years ago. But time in the parent universe, it could be trillions of years old. And time in the baby universes inside our black holes, it hasn't even started yet. Or maybe it's already finished. Relative to us, a black hole lives for eons. But inside, time might pass instantly or infinitely slow. We don't know. We can't see past the event horizon. We are locked out. But what if we could see? What if there was a way to peek inside? Or better yet, what if there was a way out? If we are trapped in a black hole, is there an exit? Is there a door? Albert Einstein found one, but he didn't like it. He called it a wormhole. But there is another name for it, a white hole. So if we fell in, how do we get out? Most physicists say you don't. You hit the singularity. Game over. But Einstein's equations allow for something strange, something that shouldn't exist. A white hole. Think of a movie of a black hole. You play it forward. Matter falls in. It disappears. Now play the movie backward. Matter flies out. It appears from nothing. It expands. That sounds impossible until you see the trick. A white hole is the time-reversed version of a black hole. It's a region of space-time you can never enter. You can only leave. And guess what? The Big Bang looks exactly like a white hole. Matter and energy exploding out from a single point, expanding, creating space. Some physicists like Nikodem Poplawski think every black hole is a wormhole to a new universe. Matter falls into a black hole in universe A. It travels through a wormhole, Einstein-Rosen bridge, and it explodes out as a white hole in universe B. Now watch what this implies. Our universe didn't start from nothing. It started from the collapse of a star in a parent universe. That collapse created a black hole. And inside that black hole, a white hole was born, a Big Bang. We are the debris that fell through the wormhole. We are the stuff that got eaten by the parent universe. And now we are expanding in our own bubble. But wait, if this is true, then every black hole in our universe is doing the same thing. Every time a star dies in the Milky Way, it punches a hole in the fabric of space-time. It creates a tunnel to a new place. A baby universe is born on the other side. And that baby universe has its own Big Bang, its own white hole.